All right, Art22, here we are again, still talking about arrays today, and we're going to be talking about a particular type of array, which is the pixel array. So we've seen before that we can create our own arrays in processing. In the last couple of lectures, we saw that we could make arrays with integers, strings, floats. We saw we could make one with images. Now we're going to be talking about the pixel array. So what this is an array that's built into processing that stores all the color values for each pixel in our window. So at every single pixel on the screen, that's in our window, the pixel array is going to store what color it is. So for example, RGB. So let's say we had a white pixel. The pixel array for the value in the pixel array for that pixel would be 255, 255, 255, that white pixel. So let's draw this out first to see how this array kind of works. And then we're going to see 5 different examples of how we can interact with that pixel array to change things the way we want. And this is kind of cool because so far we've been dealing with drawing things kind of from a little bit of a higher level, we could say. We've been relying on 2D primitives. We've been doing shapes and images. This is the first chance we're going to be able to actually interact with the underlying pixels of all those things. So it comes with some interesting opportunities. There's a bit more control involved, and some very cool effects can be made out of it too, which we'll see in the next lecture. But first things first, let's take a look at this pixel array. So let's draw a sort of a screen with some pixels on it. So let's say that here's our screen. And let's say we have a very bad resolution screen. So there we go. So our display, let's say, has only a 4x4 resolution, which is not so great, but it's going to make our lives a little bit easier to think about it. So the way that so here in this screen, we see that we have 4 pixels going across by 4 pixels going down for a total of 16 pixels. So the way that the pixel array works is that if you remember from our other array examples, an array has elements in it. In this case, there's 16 elements because we have 16 pixels. And the way that we order them, the order of the indices of this array goes from left to right, kind of like you're reading a book. So for index 0, that's going to be our top left pixel, then 1, then 2, then 3, then 4, then 5, 6, 7, 8, 9, and so on. You get the idea. Now, the wider your display is, you're going to go, further before you go down to the next row. But that's how it goes, left to right and then down. And so this will change based on what size you tell processing to draw your window. I tend to do something like 600 by 600 or whatever, and so we're going to count all the way to 599 before we go to that second row of pixels. So why don't we get a processing sketch up and running just to see how we can start to interact with these pixels and how we can set them to be a particular color by using their index in the array. And then we'll think about some other things too. But let's start with that. Okay. Here we go, week 4, class 2A. And we're going to go ahead and set up, draw. Great. Okay. Now let's get a size going here. So how about size? We'll do 600 by 600. Okay. Great. So that's how we need to get going here. So in order to be able to interact and use this pixel array, we need to actually tell processing to load all of the pixel values, all the color values, into the pixel array. And it's actually just one line of code. All we have to say is load pixels. Turns blue, things are good. So this is like initiate the pixel array. Okay. Now we've seen in arrays before that if we want to set a particular element in the array, we need to tell processing the name of the array and then which index we want to set, and then what we actually want to set it to. So we've seen things like numbers at index 4 equals 2 or something like that. 2. So we're going to do the same kind of thing, but in this case the pixels array is just called pixels. Turns green, that's usually a good sign. Let's say we want the pixel at index 9 to be set to something. So why don't we say, let's make it red. Color 255, 0, 0. So what this is saying is change the color of the 10th pixel, right? It's index 9, but it's the 10th element in the array. So the 10th pixel to be red. All right, let's see what we get. Oops, sorry, I did 600 by 60. Let's make it 600. Okay, now if you can tell, nothing has happened. And why has nothing happened? Because anytime you make changes to the pixel array like we just did, we then have to say update pixels. This is something I always forget every time we do this lecture, and this was no exception. So let's try this again. Aha, okay. So if you can see right there, there's one little pixel that's turned red. So that's the 10th pixel of our entire thing. So we went from, top left corner, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We would go all the way over until we got to 599, and then jump back down, and the 600th pixel in our array of pixels would be in that kind of second row all the way on the left, and it goes all the way down to the last pixel. Okay, that's pretty cool. Not super interesting yet, but it's a little bit interesting just to get an appreciation for how big a pixel is on our screen. But let's do something a bit more. Okay, so let's say that this was kind of like example 1 here. We'll change 1 pixel. Give it some room. Okay, so let's do another example where we change all pixels. Change all pixels. Let's be specific here. Change 1 pixel to red. How about we change all pixels to red? So, if we had to do this with, pixel 0, pixels 1, pixels 2, we'd be here all day, and then probably even more than that. However, we've seen before, and we'll do it again, that the for loop is our friend. So that's the way that we can go through all the pixels in our array and set them to a color. So let's set up our for loop here. So for, it should look familiar. It's the same format we have been basically doing for all of our for loops. So I equals 0, because remember our index for the arrays starts at 0. So when I is equal to 0, I is less than, if you remember, we have a fancy way to figure out how big our arrays are, pixels dot length. And then we want to increment by 1, let's say. All right. And what do we want to do? We want to get each pixel. I is counting up our index for us. We want to get each pixel. So we're going to use I there. And we're going to set it equal to a color. Let's just do the same thing. We'll say color 255, 0, 0. So I'm going to comment this first example out. So the effect of this should essentially be the background function that we often run in our draw loop, right? Because it's basically going through each pixel and setting it to a color. Let's check it out. Great. So our for loop has gone through every single pixel of the array, which is what's happening here with I, and it's set it to 255. Now let's just have a little fun here. So what if I didn't want to count up by 1? What if I didn't want to do every pixel? Let's say I wanted to do every 5th pixel. So instead of I++, we're going to go I plus equals 5. So I is going to be going from 0, 5, 10, 15, 20, so forth. And let's just see what the results are. Okay, interesting. So, not sure if we expected this or not, but once we see it, it kind of makes sense, right? Because we skip 5 pixels, then make it red. Skip 5 pixels, make it red. Skip 5 pixels, we do that all the way across, and then we start again. And then we could change, I guess, the width of these stripes by increasing how much we skip. Wider stripes. So just something to keep in mind that there's, you know, we can iterate through our loops in more ways than just I++, and that will return different effects. So I'm going to say, try changing the increment amount of I, such as plus equals 50. Okay, great. So there is our second example here, where we are changing all pixels to red using a for loop. Great. All right, example 3. So let's say what our goal here is we want to change the center pixel. Change the center pixel to red. Now this is a little tricky, right? Because it's like, how on earth do we know what pixel index is going to be the one in the middle, right? Because when we're dealing with stuff that's like x and y, it's easy enough. We can say width divided by 2, height divided by 2, and that's the middle. But now we're dealing with an array where it's just counting up the whole time. So, I mean, we got 600 over here, or 599 over here. We're adding 600 each time. I have no idea what the index of the pixel in the middle is. Luckily for us, there is a bit of a magic formula that's going to become our best friend when dealing with pixels. So let's switch over to the other screen and take a look at it. Okay, so when we're dealing with going back and forth between the index of a pixel in the array, so like what number in the entire really long list of pixels it is, and trying to go back and forth between that and thinking of things in terms of like x and y, which is how we normally think of position, there is a handy little formula that can go back and forth and convert those for us. So let me write the formula, and then let's see, let's confirm that it works. So the formula that we can convert from x and y position to get the index looks like this. So it's basically the index we're looking for. It's going to equal the x position we want plus the y position we want times the width of our display. Okay, so why don't we do this? Let's say that we wanted this pixel here, but we had no idea that it was the ninth, the pixel at index 9, the 10th pixel. Just like we want to know where the center pixel is in our display, but we have no idea like what number index that is. So let's put our little formula to the test. Okay, so what is the x position of this pixel? Okay, so we're going to count with 0, so we go 1, 2. So, I'm sorry, 0, 1, 0, 1. So our x position is x equals 1. Great. Now our y position is 0, 1, 2, 0, 1, 2. So y is equal to 2. Now we kind of know that this is the 9th pixel, but this is just proving it for us. So let's plug these values in and see what we get. So we know that x is 1. We know that y is 2. And we know that the width of our screen is 4. It's 4 pixels across. 4. So let's do a little math here. 4 times 2 is 8, plus 1 is 9. So we knew the xy position of our pixel. It was at 1, 2. And it gave us the index 9, which we know from just counting each pixel that that's right. So now if we want the center pixel of our display, we can just set what x and y are, and then use this formula to get the index into the array, and then set that pixel to whatever we want. So let's put that into code and see how it works. Okay. So I'm going to just put the magic formula here just so we kind of keep it fresh in our minds. So x plus y times width. This is magic for mu. It's taking too much brain power. Okay. So what did we say? We wanted to change the center pixel. Okay. So let's make a variable called x. And we know that the middle of our screen in the x direction is width divided by 2, right? Middle along x-axis. And then similarly, we know that the middle along the y-axis is height divided by 2. Middle along y-axis. Okay, so we got those two variables. Now let's set our index using our magic formula. So this is going to give us the position in the array of our center pixel. So we know our formula. Let's make a variable called index. So index is going to equal our magic formula. So we said x plus y times width. Great. And remember that we set x to the middle, we set y to the middle, and width is just width. Now let's set a pixel like we did up here, but instead of setting it to, 9, where we can expect to find it up in the top left, we're going to use our index variable, which should be the index of our middle pixel, to change its color. So let's confirm that that works. So I'm going to say pixels at index will equal, let's make it red, and I'm going to comment out the stuff before, just to keep things consistent. All right, so let me get this commented out. All right, let's take a look. Okay, again, a little hard to see, but we can see right there in the middle of our screen, we have one tiny little red pixel. Very cool. So this formula is the way that we can go back and forth from the way we like to think about position, which is in terms of x and y, and the way that pixels has to think about position, which is, it's a long list of every pixel value, and the way you access that, like all arrays, is by using its index. So we can set our index to what we know is our x and y position, and then multiply by width, and that's going to give us what we want. Okay. So let's do this. Let's do one more example just to highlight how this kind of magic formula business works. So we're going to redo our changing the background function here, like kind of our homebrew background function. But instead of using just pixel index and then going through all of the indices of the array, we're going to use the way we like to think about pixels, which is in terms of x and y. And this is going to be something we haven't seen before, because we're going to use something called a nested loop. And it's a little scary at first, but it's a good way to introduce it, and we'll get a lot more practice going forward. So we are going to change all pixels using x and y with a nested loop. Okay, let's see how this works. So basically a nested loop means that there's a loop inside of a loop. It's like loopception or something. So here we go. Let's get our first loop. So this one's going to be for our x coordinates. So we're going to say for int x equals 0, x is less than width x plus plus. So what this is going to do is it's going to go count through all of our x pixels going across our screen. You can see my mouse here at the top. I'm going to start at 0, and then x is going to get bigger and bigger and bigger and bigger and bigger until we get to the width of our screen. Now this is where our second loop comes in. So now we're going to do another loop for int y equals 0, and y is less than height y plus plus. Let's get our semicolons here. Okay. So now what's happening, let's switch over to the other screen just to get a clearer idea of what's happening with this nested loop. Okay. So I'm going to basically put a little mark every time as like an example of how the x and the y loop are working here. Okay. So at the beginning of this loop, we know that x is 0 and y is 0. And so x is 0, and then we get into our second loop, the y part. So x is holding at 0 here, but y is going from 0 to height. So we got 0, 1, 2, 3. We've hit our height. Now we go back to the x loop. Now x gets bigger by 1, so now x is 1 because we have x plus plus. So x is going to hold at 1, and we're going to go down to the height again. 0, 1, 2, 3. Now let's make x 2. 0, 1, 2, 3. Now x is 3. 0, 1, 2, 3. Think of it sort of like scanning through every single pixel, because we have an x variable that is counting across the screen for us, and a y variable that's counting down the screen for us. So x holds at 0, and we count all the pixels down. Then x gets bigger by 1, go all the pixels down for y. Then x gets bigger by 1, all the pixels down for y. That's how this nested loop is working, and that's how we can use keeping our idea of x and y in order to change every single pixel on the window. So let's see the rest of this now. Okay, so we have this nested loop, which is going through every single pixel on our screen. But now what we need to do is, and let me comment this out. Now what we need to do is the same thing we did before, which is we need to convert from x and y into the index value for each of these pixels. So we've seen that before. We're going to use our magic formula, int index. It's going to equal, if you remember our formula, x plus y times width. So x is going through this loop, y is going in this loop. We're going to use at every single point in our loop, we're going to get our x and y value and convert it into an index for our array. All right, so we've set the index. Now we just set the pixel. So we'll say pixels, index. And what is that going to equal? Well, let's just keep with our red theme here. Color, red, 5, 0, 0. Oops. Okay, let's run this. And there we go. So this is the same result as what this did, but in this example, number 2, we treated position in terms of just the index in the array. We just said, okay, we don't really know exactly where these are, but just go through every single element of our array and change the color to red. This version does the same thing, but at least now we can, other than kind of getting used to the nested loop thing, which is a little bit complex for sure, but once we get used to that, what's nice about this method is that we're able to think in terms of X and Y, so in terms of locations that we can imagine on the screen, but then still use the pixel array to change colors. Let's just illustrate one more example here. So this nested loop is going through every single pixel. We're going all the way to width, we're going all the way to height, and scanning through every single one. What if we said that we only want to go to width divided by 2? So we're going to stop when we get to width divided by 2 for X. Let's just see the result. Aha, okay. So because X starts at 0, and then we go all through the pixels going down. Then X is 1, and we go through all the pixels going down. We keep doing this, but now we're telling X to stop at width divided by 2. And then we come back over here. So you can control where we're drawing these pixels because we're now thinking in terms of X and Y, which is how we like to think about things, but we're still using this index array. Let's see what the effect would be if we also had height divided by 2. Okay, so now we are stopping X at halfway through, but we're also stopping Y at height divided by 2, so midway down. Okay. Great. So we're just going to do one more example here, which is a bit more fun and a bit more maybe not more complex, but there's just a couple more elements to it. So what I'm going to do is just comment out this for the moment. Great. Actually, you know what? We're going to end up using this nested loop, so I'm going to grab that. And now we can comment this out. All right, so now we're going to do a little bit of a special effect with our pixels, just to see a more creative application for using our pixel array. And it's going to draw on the map function, which we've seen before, but it'll be good to get a little bit more practice with it. All right, so first things first, we're dealing with pixels, so I'm going to say load pixels up here at the top, and then update pixels at the bottom of our draw loop. Just this way that every time we make some change here in our draw section, we make sure that we load and update pixels every single time. It's good practice. Okay. So why don't we go ahead and put our nested loop here. So let's copy and paste that. I'm hitting Command T to format it. And I'm going to just make some space here. So we're actually going to be using the same structure as we did for number 4. We're doing a nested loop. So say nested loop to go through all pixels. Let's say all pixel locations. Converting to index number for the array. And then down here, we're setting color of the specific pixel at index. Okay, great. All right, so now what I want to do is make this a bit more interactive. So we're still going to set index to whatever pixel we're currently looking at in our loop. But now we're going to introduce the mouse into this situation. And we're going to basically have a method here for changing the color of the pixel based on its distance to the mouse. All right, sounds a little bit scary, but it's only actually 3 lines of code, and let's see how it works here. Okay, so first things first, if I said that we want to calculate color of the pixel based on its distance to the mouse, so how far away is it from wherever my mouse is, we need to first figure out what these distances are. So luckily, processing has a built-in distance function for us. So we're going to say, let's make a floating point number, a decimal number, variable. Call it d for distance. All right. Now the function for distance in processing is just dist, turns blue, it's a good sign. And now what distance wants is the 2 points that we're trying to calculate distance between. So one of them is my mouse, and the other one is the X and Y position of whatever pixel we're looking at the moment. So let's say we want to find the distance between X and Y, and remember that that's happening for every pixel. So for every single pixel, we're calculating the distance between the mouse and wherever that pixel may be on the screen. And what's the coordinate for my mouse? Well, that's just the built-in mouse X, mouse Y. So this is get distance between pixels location, X and Y, and the mouse position. Great. Okay, so now we're going to get some number that will be, we don't know exactly, if it's really close to the mouse, it might be like 1 pixel. If it's really far away, it might be like, 600 or something like that, because our width here is 600. So what we need to do is, so those numbers don't quite fit with our color, which is how we want to use them. So we're going to use that map function that we've seen a little bit before. So I'm going to make a new variable called MD. So this is going to be for our mapped distance. And we're going to say, let's map that distance number that we just calculated, which is somewhere between like 0 and 600. So that's its initial range. Think about this, for example, if my mouse is all the way over here on the right, but we were trying to get the distance between the pixel that was all the way over here on the left, that distance would be 600. So that's kind of our maximum distance. I mean, we could probably have more if we had the diagonal, but let's just go for 600 at the moment. It's not a precise science right here. And then what do we know the range for color? We know the range for color is 0 to 255. So we're going to take that range from 0 to 600 and change it to 0 to 255. So now we should be getting numbers for MD, our mapped version of distance, that is actually now in the range of color that we'd like to see. Okay, so now let's actually use that. So let's say map pixel distance to range that works with color. Now instead of just changing everything to be red, what we're going to do is we're going to change it to be the color MD. And let's see the effect of this. Oop, I forgot we're still doing width and height divided by 2 at the moment. So let's go back and do the full display, not just by half. Okay, let's try that again. All right, very cool. So let's think about what's happening here. So let's say my mouse is right here, and the values closest to my mouse are darker, with them being fully black right next to the mouse. And then the further we go away, the values get to be lighter and lighter and lighter until they get to white. Now, why is that happening? Okay, so let's think about this. Let's think about a pixel that's very close to my mouse. The distance might be, let's say, 5. It's 5 pixels away. So then we're going to map that to the range that works for color from 0 to 255. So that's going to be probably even smaller, probably like 0 or 1 or something. So what is 0 or 1 in terms of color? Well, we know that when we're doing color with just one variable, we're working with grayscale. So 0 is all the way black, 255 is all the way white. So that's why we're getting this result where the closest pixels are much darker, and the pixels that are further away have a higher value, the distance is greater, and that means that the color is brighter too. And we could do this in the inverse as well, actually. Let's say instead of mapping it from 0 to 255, let's do it the other way around. 255 to 0. All right, now we have the opposite, right? The pixels that are closest to the mouse are whiter, and then the pixels that are further away are black, kind of have like a flashlight effect. And now we could tailor this a little bit. For example, maybe we want to pretend like the distance doesn't go all the way from 0 to 600, maybe it's only from like 0 to 300. Let's just see what the result is. There we go. So we can see that we have a little bit of a tighter kind of, it almost looks like a 3D sphere. And so this is a great example of how just sort of tweaking values and just kind of playing around in code can be a great way to come up with ideas that were unexpected or, a little bit surprising but interesting. So let's just switch that around one more time and then go back to 0 to 255. So we're going to go back to being darker, closer to the mouse. And there we go. Now we have yet another effect. Okay. All right. So this is a kind of a weird new way to think about things with this idea of pixels being in an array, and then for us to try to figure out which ones we want to change, we have to convert them from how we think about space, which is in X and Y, and then turn that into the index within the pixel, so the position within the pixel array. We'll get more practice with this. Next lecture, we're going to see, I think, a much more interesting way to make some cool effects happen with our pixels. And but we'll keep getting more practice, and we'll see you next time.